Hello, everybody. Let's go ahead and start 2.1b, basic rules for exponents. And this is not much of a departure from the previous lesson, really. I mean, we're kind of continuing on maybe just a little bit. The problems are a little bit more sophisticated. There's a little bit more to them, but we're going to still follow those general rules of order of operations and making sure we deal with the exponents first. Make sure you take care of simplifying all exponent parts of the problem and then multiplying last and doing any simplification, perhaps, if you can. And so that's the only note I put there for the steps for combining rules of exponents, which is just keep following order of operations. You know, that's really important. Just kind of keep that in the back of your head. That is something you need to follow all the time, not just with this stuff, but with every math problem that you ever do for the rest of your life. Okay, so going on to number one right there, we've got 4h, and that's squared, and we have 3h to the 7th, that's in parentheses, and that's cubed. So let's take care of the exponent parts of that problem, and then when we're all done, let's multiply those parts. We're going to multiply this part, whatever that comes out to, by this part, right? So let's take care of the exponent first, like I said. Let's do that first. So we're going to do 4 squared, which is 16, and then h squared. So pretty simple thing right there. And then we're going to do 3 cubed. This 3 is going to apply to the 3 to the base and h to the 7th. So 3 to the 3rd power is 27, and then h, and then this is a power to a power, so we're going to do 7 times 3, which is 21. Okay. And then we're going to do the next part. We're going to do 16 times 27. Okay, so we're going to do 16 times 27. So you do that. 16 times 27 equals 432. The coefficients multiplied out to be that. And then we're going to treat the exponents not like multiplication, but we're going to use a product rule, which means we're going to add the 2 and the 21, which makes 23. That's it. Okay, number two, let's just do the same thing we were doing for number 1. Let's take this and apply it to everything that's in the parentheses. Take this squared part and apply it to everything in there, and then multiply those 2 parts separately or together when we're all done with it. You know what I mean? So we're going to do 2 to the 3rd power, which is 8, and then x cubed, and 2 squared, that makes 4, and then x squared. All right, now this multiplication is definitely easy. All you have to do is 8 times 4, which is 32, and then use the product rule of adding the powers. 3 plus 2 makes 5. Right? It's not a power to a power. Power to power looks like, well, looks like this, you know, like I had a 3 here, you know, or if I had a 4 right there or something. That's kind of like what that looks like. All right, for number 5, all right. Now, one thing that you might want to do for this one is, especially since it's a fraction, it's in ratio form, is you're going to want to reduce the fraction, you know, and in this case, it does reduce. 3 over 6 can reduce to 1/2, right? 1/2. So you can work with those numbers, and then that will leave less simplifying when you're all done. You know, so sometimes when you simplify it before you take it to a power, you know, sometimes when you take it to a power, it gets much, much bigger, and then it becomes a little bit more difficult to tell what you can reduce it by. But when they're in fraction form, as it is, it's much easier to kind of spot how it reduces, you know? So that is what I did. And so we're doing on the top, we've got 1 cubed, which really is just 1. And then d squared cubed, which is 6. That's a power to a power right there, right? Power to a power. And then we're gonna, on the bottom, we're gonna do 2 cubed. Okay, and then I'm gonna work all that out. So 1 cubed is just 1. D to the 6 is unchanged, and then 2 to the 3rd power is 8. And like I was showing you before, another way to write that would be as 1/8, and then you can put the d, the variable part with the exponent right in the middle. So 1/8 d to the 6. Okay, so that's all you have to do for number 5. All right, kind of going in a weird order here. Let's go to number 4. Number 4, we've got this part right here, which is just like, right, just begging you, this part right here, it's begging you to multiply. Like, just multiply it. -3 times 4 is -12. So easy, but we cannot do that first. That's multiplication. We've got to take care of the power first. We've got to apply that squared to everything. So 4 squared, a squared squared. That sounds kind of weird, but a squared squared, and then b cubed squared. Okay, so it's going to apply 3 different things. So hold on to that -3. I know it's really tempting because it's right at the beginning of the problem. You're like, I must do something with it, but you don't have to, or you cannot, you must not. So let's leave it alone. Leave it there in the front. And then 4 squared is 16. A squared squared is 4, so a to the 4th. B cubed squared is 6. So we're doing power to a power rule when we deal with that. We're multiplying. Okay. And now we can multiply the -3 by what is in the parentheses. So we're going to do -3 times 16, and that's it. The -3 does not affect, oops, I didn't mean to erase it there, does not affect these things, right? The coefficient is only going to affect the other coefficient. So -3 times 16, -3 times 16 is -48. And then leave a to the 4th and b to the 6th alone. Don't touch it, okay? Don't do anything with it. All right, now last example here on this page, number 6 is now you're going to notice that we have a fraction again, and the fraction appears, like I was saying before, it may appear like you can reduce like the 12 and the 4, which very well could, that if things were just right, we could, but we cannot. And the reason for that is because we don't have exactly the same base. Notice we have 12y cubed here, 12y cubed here, and we have 4z to the 10th there. So those bases, if they were exactly the same in the numerator and the denominator, now never mind this thing, that doesn't matter. What matters is what's inside that parenthesis. If those were exactly the same, then we could reduce the 12 and the 4 to 3/1, right? And that would work. But since those are not exactly the same base, we cannot deal with them that way. So let's go ahead and work the top out and the bottom part independently, okay? And then when we're all through, we can reduce and simplify because that's division, essentially. So we got to take care of multiplication first and deal with division last. All right, so that is what we're going to do. So 12 squared is 144, right? That's all I'm doing, 12 squared, and then y cubed squared, which is going to be y to the 6. All right, and then we're going to do the same thing right here. We're going to do 4 cubed, and we're going to do z to the 10th cubed. So 4 cubed is 4 times 4 times 4, which is 64. And then z to the 10th, that's a power to a power. Z to the 10th cubed is going to be z to the 30th. Z to the 30th. Okay. And now we can reduce. We can reduce this. So you might not off the top of your head know what the GCF is, 144 and 32. But I mean, if you do, great. But I'm just going to do this kind of the normal, typical way that an algebra student might do it, which is I'm just going to I'm going to keep dividing by 2. So half of 144 is 72, y to the 6, and half of 64 is 8, z to the 30th. Now notice I didn't touch these things. Those do not divide. Those don't simplify like the coefficients do. The only thing that can simplify those exponents is if I had a like exponent, just like it, like a y to the 6 on top and a y something else in the bottom, but we don't. Okay. So let's keep, oh wait, I did that wrong. I was dividing by 2, wasn't it? 64 divided by 2 is 32. Pardon me. Sometimes my mind is thinking one thing and my hand does another thing. Just let me know if I screw something up. I'm a human being. I can make mistakes. All right, so you got 72. Let's divide that by 2. So half of 72 is 36. Y to the 6 is unchanged. Half of 32, we'll do this right this time, is 16. Z to the 30th is unchanged. All right, and it looks like those are divided. We can divide those by 2 again. Half of 36 is 18. 36 divided by 2 is 18. And then half of 16 is 8. And it looks like we can keep going here. I know it's like, what the heck? But 18 and 8 divided by 2, that's pretty simple math right there. You got 9, y to the 6, and then 4 z to the what? 30th. That's it. Now, if you're super like awesome with your like understanding GCF and all that stuff, you could have, I mean, if you wanted to, you could have just recognized, and I wouldn't have recognized this off the top of my head. You could have just divided the top and the bottom by 16. But oh well, we just divided by 2 4 times, which is 2 times 2 times 2 times 2 is 16. See, that kind of weird. But yeah, that's it. We are through. Okay, so that does it for 2.1. What is it? What did I just do? That was 2.1b. I wanted to say 2.1a, but that does it for 2.1b. I'm going to go ahead and stop there for this lesson. I'll do another lesson for 2.2a. I'll keep making lessons. Okay. All right. That's it. See you at the next lesson.